All right, class. So in this limit, if we substitute infinity into it, we get infinity over infinity. Therefore, L'Hopital's rule applies. Connor, wake up. Connor, wake up. What rule do we use?
The hospitals?
No, it's not L'Hospital's rule. It's L'Hopital's rule.
I'd rather go to the hospital and do this. And when the function am I ever going to use this in real life?
Have some imagination here. Imagine you have a 6-foot man.
I don't care about 6-foot men.
Class dismissed.
Hate this class.
Hello? Alright, I'll see what I can do.
You there! You look like a calculus student.
Who are you?
I have many names, but you can call me DX.
Like a derivative?
Ah, so you are a calculus student.
I am, but calculus seems like such a useless subject.
It's as useless as you're willing to make it.
Wait, where am I?
This is the hub. Within the hub, you can view anyone, anywhere, at any time through the use of this patented technology. Have a seat.
Okay.
Let's fix that outfit of yours.
What am I wearing?
So, you think calculus is useless, huh?
Yeah, I just can't think of a time where I would ever use calculus.
Well then, let's take a look at a real-life application of calculus. A man is driving in a residential area going the legal speed limit when suddenly a baby falls onto the road. At the moment the baby falls onto the road, you, a bystander, are 20 feet away from the baby and the car is 100 feet away from the baby. The angle formed by you, the baby, and the car is 90 degrees. In order to save the baby, the distance between you and the car has to be decreasing at a rate of 32 feet per second. How fast do you have to be running to save the baby?
Okay, so we're given that the angle between me, the baby, and the car is 90 degrees. So I'll label this between the car and the baby as X. And this is between me and the baby as Y. This between me and the car is Z. So the car's speed is dx/dt. Wait, what is the legal speed limit? 20 miles an hour? Okay, that's 29 feet per second. And then to save the baby, you have to be... the distance between me and the car has to be decreasing at a rate of 32 feet per second. And it's negative. Okay. So the distance between the car and the baby is 100 feet, and I'm 20 feet away from the baby. So if we use the Pythagorean theorem, we get x squared plus y squared equals z squared. When we differentiate that, we get 2x dx dt plus 2y dy dt equals 2z dz dt. So we can just cancel out the 2's. When we rearrange the equation for dy dt, we get z dz dt minus x dx dt over y. If you're wondering where I got z from, I did some off-camera calculations using the Pythagorean theorem. It's pretty trivial. So we get that I have to be running at 18 feet per second. Alright, so I have to run at 18 feet per second to save the baby.
Congratulations, you are terribly wrong.
How am I wrong?
Your mistake is that you assume that the legal speed limit with a residential area is 20 miles per hour, when in fact it's actually 25 miles per hour. Meaning that the speed of dx over dt is not 29 feet per second, but actually 37 feet per second. So what this means is the baby is now dead.
Oh my god, so the baby's now dead because of me?
Correct! Next application.
Read and weep. It's been fun playing with you, poor boys.
The winner you just saw there is named Aaron. Aaron is a chronic gambler, and the rate of change of the money in his wallet is modeled by this function, where t is measured in days. If Aaron begins gambling with $959,000, when would be the best time to rob Aaron?
So f prime of t gives us the rate of change of Aaron's money. So the relative max happens when f prime of t goes from positive to negative. So if we use a graphing calculator, we can see that there's a relative max at t equals 1.917 and t equals 8.2. Using the fundamental theorem of calculus, we get that the integral of f prime of t from 0 to x is f of x minus f of 0. We can rearrange this into f of x equals f of 0 plus the integral of f prime of t from 0 to x. To find the absolute max of Aaron's money, we have to plug in the endpoints and critical numbers. At t equals 0, he has $959,000. At t equals 9, which is the endpoint, he has negative $2,448,000. So he's in debt here. At t equals 1.917, he has $4,427,000. At t equals 8.2, he has $1,286,000. So he has the most at 1.917 days. So that means at 1.917 days, that is the absolute max of his money.
So I should rob Aaron in 1.917 days.
That is correct. In 1.917 days, Aaron will be at his richest and at his best time to rob him. So, have at it.
Stick him up! Hand over your money or I'll put a discontinuity in your brain.
How'd you know I had this much money on me?
Easy. I use calculus.
Who are you?
They call me the Mathnasium Menace. See you around, poor boy.
So, how'd it go?
Great, I got all the bands.
Nice. Well then, that brings us to our final application and your redemption. Aaron is home now and he's having a drink in his kitchen when suddenly his baby crawls into the kitchen. Aaron knocks off a knife from the counter and the knife is falling towards the baby. The knife falls off of a counter 3 feet high. How much time do you have to save the baby?
The acceleration due to gravity on Earth is negative 32 feet per second. If you integrate acceleration, you get the function for velocity. So the integral of negative 32 is negative 32t plus c. C is 0 because the object starts off with 0 velocity initially. And if you integrate velocity, you get the function for position. So the integral of negative 32t is negative 16t squared plus c. The object is initially 3 feet above the ground, so we get that c is equal to 3. And the position function that we just derived is negative 16t squared plus 3. The baby is dead when the object hits a position of 0, which is the floor. So if we set the position function equal to 0, we get 16t squared equals 3, and then t equals square root of 3 over 16, which we can simplify into root 3 over 4. Root 3 over 4 is just approximately equal to 0.433 seconds.
What? I have 0.433 seconds?
That is correct, and those seconds start now.
I did it! I saved the baby!
Congratulations! You did it. You saved the baby and redeemed yourself. Now that that's over with. So, what did you learn today?
I guess calculus isn't so useless after all. I managed to do a lot with it today.
Calculus is a part of everything. Every line, every curve, every infinitesimal little point of change we have. Math is everywhere. Calculus is a part of everything in this wonderful mathematical world. Well then, let's look at a
One. One.
Congratulations, you've done it. Slip the baby.
Read him and weep. Wait, what? No.
How fast do you have to be running to save the baby?